service, right? Today we will talk about introduction to functions. What is the function? And it's kind of a quick and dirty way of presenting functions. So let's get started. Primarily, we are going to look at how do we identify a function from a graph, table, Venn diagrams, and then talk about domain and range, and a couple of common functions. We'll go over that. And these are the common functions that we're going to go over that. So from linear all the way to greatest integer function. Okay, so let's get started. All right. Now, how do we identify a function from a graph? Let's say you have a graph of a relation. The horizontal axis traditionally is x, vertical axis is y, and you have a function. Just goes forever. What we call a vertical line test, and I'll explain that. Think of a vertical line and pass that vertical line through different random locations on that curve. If it hits that curve, only one location, that is a function. Now, how can it not hit one location? It can happen when some goes like this, for example. So when you go and hit it, oh, look, it hit it here and hit it here. Not a function. How about this one? Okay, here we go. Hit it only. That's a function, okay? Function, not a function. Got it? All right. So let's talk about identifying it from a Venn diagram. It is actually a little bit easier to do that. What's a Venn diagram? It's like a little bag where you put things in it. Okay? So let's think of a bag and another bag, and there's a relation. This bag has like 1 and 2, and then this one has 3 and 4. Two things, just number 1, number 2, number 3, and number 4. There's a relation between 1 and 3, and there's a relation between 2 and 4. Actually, what is the relation? You're just adding 2. Okay, that's fine. 1 goes to 3, 2 goes to 4. Okay, what's that mean? If one thing goes to one thing goes to one thing, that's a function. Let's think of some like this. Let's say I have 1 and 2, and then you have 3. One thing goes to 3, and 2 also goes to 3. All right, that's okay. That one is also a function. Well, what is not a function then? Let's think of this. 1 goes to 2, cannot make up its mind, and goes to 3 as well. So one thing goes to two things. That's not a function. All right, how is that related, a function and one thing going to two things? One thing, that means your start point. It's kind of like your x. This is kind of like your y. Let's look at this graph. I just told you, this one is not a function. You have one x, it goes to this dot and that dot. One thing going to two dots. That's why it's not a function. Does that make sense? So actually, what you're doing with the vertical line test is kind of like visualizing this Venn diagrams. Well, how can you identify it from a table? How do I do it with a table? Well, you're going to have the same thing with the table. Let's look at a table of A. If they gave that in a tabular format, it would have been 1, 2, 3, 4. And in your head, you would have just kind of like visualized the Venn diagram and say, yeah, it's a function. Let's make a table of B. What would that look like? It would be X and Y, 1, 2, 3, 3. 1 goes to 3, 2 goes to 3. Okay, good. That's also a function. All right, how about this guy? Not a function one. If you were to do that in a tabular format, X, Y, you have a 1 goes to 2, 1 goes to 3, right? So in a table format, you can also realize that that's not a function. All right, so we did it from a table, we did it from a graph, we did it from a Venn diagram. So that's good. Now let's look at domain and range. Let's go back to the Venn diagrams. Remember, you have a function, let's say 2 goes to 3 and 4 goes to 5. And here's a relation, and that relation happens to be a function. So this arrow represents a function. What does the bag itself represent? That first bag that you start with, that's called the domain. And usually it's like this squiggly, fancy capital D. And the second bag is called the range. And again, a squiggly capital R. Okay, so what is the domain of this first thing? When you list things, you use braces. 2, 4. What's the range? There are two things in there, 3, 5. Does that make sense? All right, let's look at domain and range of a graph. Let's think of a parabola. Let's say it's like this. It passes the vertical line test. Okay, and this is 1. So what is the domain? And what's the range? Domain are all x-axis, because that thing goes forever that way and that thing goes forever that way. If you look at the x values, it is all real numbers. You can write it like this. X such that x is a real number. What is the range? Problem is, it starts from here and goes up. So it doesn't have any value lower than 1. We are looking at the y values. This is like x values. These are like y values. What is the smallest y you can imagine? You can write it like this. Y such that y is greater than or equal to 1. Oh, I see it. Okay. Well, you can also write functions as x and y. So we just said, okay, let's think of f of x is like 2x plus 1. So you represented a function with the function notation. So what will that function notation do? Think of a domain of all possible numbers in here. And the range, for example, 1, where will 1 go with that function? That function is going to take 1 and multiply by 2 and add 1. 2 times 1, 2, plus 1, 3. What will it do to 5? You can do that for every single number. 2 times 5, 10, plus 1, 11. So 5 will go to 11. You're going to have all these things. So it's a little easier to write this. What's your domain then? I can plug in whatever I want. All real numbers. Well, can you also write that in interval notation? Of course, negative infinity to infinity. Well, how about set builder notation? X such that x is a real number. Good. Now, how do I write the range? Well, we said the range is going to be 2x plus 1. Think about it. 2x plus 1, what does that look like? Here's the intercept of 1 and a slope of 2. So it goes forever. There's no limitation. It doesn't stop like the parabola does, okay? It just goes forever, as low as you can, as high as you can. So what is range? Range is also all real numbers. Okay, well, let's do another funky one. How does that work? Let's look at, let's say, let's insert a couple of pages. I think I have enough. Okay, let's look at a funky one. Sometimes it's temperamental. F of x equals 2. What does that mean? Y equals 2. What's that mean? It means my function is doing that. Does it pass the vertical line test? Absolutely. But let's look at the domain and range of that. Can I plug in any x? The x is not even in the picture. Yeah, all real numbers. For any x, I get 2. All real numbers. Well, how about the range? What's my range? Whatever I put in for x, I always get 2. Only one thing. So how do you list it? In braces. All right. So when a line has some kind of slope, all real numbers domain, all real numbers range. What is the flat line? It's going to be just one thing as output. How about a vertical line? Well, the problem is vertical line fails the vertical line test. So that's not a function to start with. Okay, so let's look at some common functions, and we start with the linear functions. You can go and watch the linear functions and graphing and stuff like this in the beginning and intermediate algebra videos, but this one at the college algebra level, I will assume that you know what you're doing. So let's assume f of x equals 3x minus 5, a function. Does it pass the vertical line test? Yeah, all that. This is called the linear function. Its picture is a line. So it has an intercept of -5. And it has a slope of 3. So your line kind of looks like this. A linear function. Passed the vertical line test. And it is good. The domain is all real numbers. Sometimes I don't want to write all real numbers. Here's another one you'll see in some books. Double bar R. And somehow all the math people know double R means all real numbers. Okay? How about range? The fancy R. Don't mix it with the double R. That's also all real numbers. Okay, so that's your first function. Okay, how about a square function? Here's your basic square function, x squared. What is its picture? Just memorize that. It's a parabola. Your basic parabola. Here we go. Put arrows on both sides. A square function. Okay? How about a square root function? Well, the thing is, when you have a square root, what is spitted out is always positive. So that means you start with 0, and then it's not really straight. Let me put a little curvature in there. Here's your square root function. Okay. Oops, I misspelled the root. Okay. Now, let's go back. I forgot to do the domain and range of this guy. Can I plug in anything? Yes. How about range? Where does it start? It starts at 0 and up, so it's going to be 0 and up. Square root function, on the other hand. Okay? What is your domain? Can you take square root of a negative number? No, not in the real domain. So, can you take square root of 0? Yeah. So, it goes from 0 to infinity. All positive numbers, including 0. What's your range? What spit it out is also 0 to infinity. Does that make sense? Because you are in this location. Okay, what else do you have? Cube function. F of x equals x cubed. Know this by heart. What does this look like? It's going to wiggle. Okay, what's its domain and range? Can you plug in anything and take the cube of it? Of course. All real numbers. How about range? Do I get negative numbers unlike the square root? Yeah. All real numbers as well. Cube function. What else do you have? The other one, a cube root function. When you plug in some numbers, you're going to see how that works. But it works some like this. Cube root function. Okay, can you take cube root of a negative number? Of course. What's your domain? All real numbers. What's your range? All real numbers. Cube root function. Know the shape of it? What else? Now, piecewise functions and absolute value function. So let me go to absolute piecewise. What a piecewise function is, you usually write it like this: f of x equals, and now you put braces in here, and you put some expression in there, and you say, well, this is true when x is less than 0. And then x squared, and this is true when x is greater than 0. Okay, what's that mean? Let's look at that. What does y equals x look like? It looks like this, right? Okay, but I do not want this part, right? Because I want to stay at less than 0. So you take that out. You do this in red. So here it is. Oops. That's what it looks like. I just did it squiggly so you can see it. You can just do it solid. Okay, x squared. What does this look like? That's in blue. X squared looks like this, but this part I don't want, so it looks like this. Alright, so this piecewise function looks like it does some somewhere and some else. And absolute value is actually a perfect piecewise function. Let's look at it. You probably remember absolute value from your 6th grade math class. This is the definition of absolute value. F of x is absolute value of x. What does that mean? That means it's going to take a negative number and make it positive. And it's going to take a positive number and leave it alone, including 0. Okay, what's that mean? Okay, what does y equals negative x look like? It looks like this. This is in red. Here it is. And this part is not going to come in the picture because you're taking that out. It only is, and then you have a hole here. And it goes forever. How about positive x? What's that mean? That means y equals x. And this part you ignore because it's in the negatives. And then this one has the equal. So the absolute value function is just the v, including 0. So what's its domain? Can you take absolute value of any number? Yeah. But how about the range? you always get 0 to infinity. Nothing else. You cannot do negative numbers. Okay, there's one more that I want to cover. That's the greatest integer function. And this is how you show it. F of x, this funky looking bracket, okay? It returns largest integer less than x. What's that mean? What is 0.9? Returns the largest integer less than that. What is that? 0.9? That's 0. Okay? How about 1.1? Less than that number. So that's going to be 1. How about 1.9? That's also 1. It doesn't go to 2 because less than that number. Okay, so think of greatest integer numbers like a rounding down function. Okay, so what will it look like? Okay, greatest integer of 0 is 0. 0.1 and all that, it's going to still be 0. And then when I have, let's say, 1, greatest integer of 1 is 1, but 1.1 is also 1. Does that make sense? How about, this is 1. How about 2? Greatest integer of 2 is 2, but 2.1. So it's like black on the left, hollow on the right, and then it will go like this to the left as well. Greatest integer function. So kind of will know the shapes of all these functions and know what a function is. Thank you for watching.